Hey everyone, welcome to another video or live stream for those who are watching live. I hope you've got to a new and fresh start of the day, depending on where you are. Because I know some people it's afternoon, others it's evening. For us where I am, it's morning. So good morning, good afternoon, good evening, or good night. So over the past many months, I've been building a full stack project that aimed to cover the front end, the back end, DevOps, AI, and even the plan included doing mobile development. But a number of challenges came in when I wanted to go to production. For example, getting access to use the payment gateway in production took about 2 months of paperwork. Imagine that, only paperwork. And being human, sometimes it discourages you. Okay, I got discouraged a little bit, but you never give up. You try. You get back to your feet and try to do things. So I'm back to it. And over the past maybe 3 or 5 videos, I've been preparing this project to be deployable on Kubernetes or to be orchestrated by Kubernetes. And it has been a huge success so far. So I'll be continuing that in this episode. Trust me, if you can take time to repeat these concepts again and again, you can understand them. And in the age of AI, it's becoming very important to understand how components work together and being able to understand trade-offs. And by this, I mean system design. And of course, when you're good at it, using AI even becomes much more joyful. So let's get into it. I will start off by explaining the new files, and then we can continue. So in the previous episode, we deployed the API to Kubernetes, but in this episode, we're going to deploy the worker. If you remember in the past, okay, I did a split, okay? I made sure that the FastAPI process does not depend on the worker process. In other words, we had one whole process which was responsible for receiving HTTP requests, but for also consuming events. So I split that. One process will be responsible for consuming HTTP requests, and then another process will be responsible for consuming Kafka events. And we had that very successful. Right now, the job is how to deploy it on Kubernetes. So here's the Helm chart for that. Okay, so if you don't know what Helm is, if you don't know what a Helm chart is, please check the videos in the playlist. Okay, the previous 2-3 videos will help you understand this very deeply. Trust me, you'll appreciate it. Very important. Now, let's look at worker deployment.yaml. Okay, and it's very similar to API deployment.yaml. Trust me, once you understand the past videos, okay, and come to this, and for those of you who have already been following along, this is going to be repetition. And remember, mastery comes from repetition. The more we repeat, the more we master. Okay, we need to repeat consistently these topics, and you're going to find yourself being very good at this. Okay, for me, I don't care about not understanding a concept. What I care about is being consistent at repeating to study these things, okay? Repeatedly studying these concepts again and again. So let's look at line 1. Line 1 says API version apps v1, okay? So apps v1 simply means that this is, okay, a version 1, okay? This belongs to the apps version 1, as simple as that. This is the API version for this, okay? As simple as that. If you look at config map, okay, you see this shows that config map belongs to the core API, okay, of Kubernetes, which is version 1. If you look at secret, it means that it belongs to the core version 1 of Kubernetes. Okay, but for deployment, okay, deployment is apps v1. Okay, and worker deployment belongs to the Kubernetes apps v1 deployment. Okay, not deployment, apps v1 version. Okay, v1 is the version. So for config map secret, they belong to the API version v1. Okay, but when we go to API deployment, it is apps v1. So there's a difference. I'll repeat: API deployment and worker deployment, they belong to the apps v1 version, but API service, config map, secret belong to simply v1. As simple as that. So let's go back to this file. Then for the kind, it's going to be a deployment. So you see, we have two deployment templates. We have one for API deployment. You see, it says kind API deployment. Let me reduce this. Okay, and expand maybe a little bit so that you can see it better. So kind API deployment. Then we have in the kind here, API deployment. This one is for the worker. This other one is for the deployment, the API rather. Okay, for HTTP requests. This one is going to be for consuming Kafka events. Okay, same image. We're going to use the same image. Okay, but it will help us to have two containers. Okay, one container for HTTP requests, another container for what is it called? Consuming Kafka events. As simple as that. All right. So line 36 metadata. Okay, we give the name of this deployment. It will be release name. Okay, then worker. So the release name will be displayed right here. Okay, how do you get the release name? When you say Helm, okay, then for example, then you say template. Template is a command used to display or produce Kubernetes manifests without deploying the application. So when I say Helm template and then say aero-backend, aero-backend is the release name, and that release name will be replaced right here where I've selected, where you see my mouse selecting everything. Okay, so it will be aero-backend-worker. That will be the name of the worker deployment, and you shall see, we shall test it, and I'm going to deploy it. Awesome. After that, we have a block that says spec. Okay, so I'll repeat again. Line 1 refers to the API version. Okay, it says that this configuration or whatever, this resource we're going to create, which is called a deployment, belongs to the apps version 1 of Kubernetes. Then on number 2 or line 2, we're simply saying that the kind of resource or the kind of Kubernetes object we want to create is a deployment. Then metadata simply means information about this deployment. Okay, and what we want to give, or the kind of information we want to give, is the name, which will be the release name, then a dash, then worker. All right, nice. Then after that, we have the spec. Spec simply is a short form for specification, okay, or configuration. The first spec will be values.worker.replicas, meaning the number of replicas. And this comes from the values file. If you go to values.yaml, okay, you see we have here worker.replicas. So I also added this, the configuration, to tell us how many copies or duplicates or instances of the worker pods do we want to have. Okay, and for now the value is 1. So this value will be got right here into this, okay, using the values object. So values.yaml, okay, when you have a values.yaml, Kubernetes will use it to create a values object. Okay, and from that values object, you shall be able to say things like values, okay, dot worker, where worker is this configuration here, then dot replicas. Okay, and of course later we can be able to change it. Okay, and I'll show you how in a future video. All right, next up we have selector. Okay, selector, match labels app, okay, release name dash worker. What is this? Selector is simply, like I explained earlier in the previous live stream and video, it means that it is going to help us to find, okay, to search and find for pods that match a particular label. Okay, and the label will be aero-backend, which will be the release name dash worker. So selector match labels is simply a label, okay, for the purpose of searching and finding. Where will it Not where, but how will it know that it has to search and find for a particular name? That is when you go to template, okay? So if you look at this select and match labels, okay, this first part you're seeing, line 6 and line 7, are configuration or specification for the deployment. But when you go to template, then you have specifications for the pod, okay? So in the pod, we shall have another label, okay? Template, metadata, labels, okay, with the same name, okay? This will cause Kubernetes to create labels, okay? It will cause our pods to be labeled this way, that we have a pod or pods labeled with the release name dash worker, okay? In our case, the release name will be aero-backend. So it will be aero-backend-worker. So once the pods, okay, or Kubernetes creates pods with a label, okay, like so, then the selector here, okay, the deployment can use its label here on line 9 to search and find for pods labeled at, or using the label at line 13, which means line 9 and line 13 must match. If they don't match, then you'll have an error, okay? Or you'll find that things hang forever. So make sure that the two match perfectly well, okay? Make sure the two match perfectly well. You really need to ensure that. Okay, now let's move on to the other configuration. That would be down here. So I'll close this. Again, this is a repetition of what we've been doing. Okay, then we come here to spec, which is the, let me drag this down. Sorry, this will be the pod specific specification. Okay, so in spec here we have the first one, which says auto mount service account token false. This one is simply a configuration which turns off the creation of a token. This token is mounted on every pod, and the purpose of this token is to help you and your application communicate, make requests to the Kubernetes API. To make requests to this Kubernetes API, you need to authenticate. Your application needs to authenticate. But in our case, we don't need to authenticate with the Kubernetes API because we don't need to communicate to it. So because we don't need to communicate to it, we don't need that token to be mounted to the pod. Hence, we say false, as simple as that. Then we have the containers. In containers, we have only one container. It is called worker. Do you see that everything is the same? Not the same, but similar. Okay. So you see all these blocks in worker deployment are also in API deployment. Okay. So it is called worker. When I open it, okay, we now have the image. Okay. The image will be image, okay, values.image.repository. That comes from right here, values dot image dot repository, as simple as that. Okay, then the next one will be values dot image dot tag. Okay, the same awesome concept. Okay, image pool policy, okay, which will be the policy that determines whether an image can be pulled or not, or a local image can be used. For what we have here, if not present, it simply means that Kubernetes will use the image on our local node. Otherwise, it will pull it from the registry. Okay, as simple as that. Then we have a command. Command says, what binary are we going to run? It is this one here. Okay, it's the Python. Okay, remember in API deployment, we run a different one. We run the FastAPI. But this side, we are running the Python. So two different things. Okay, here we start the FastAPI server. Here we're going to start the Kafka worker. So it will be Python -m for a module. What module are we running? Backend.worker. As simple as that. So you realize we're using the same image and same tag. Even here, we're using the same image and same tag, but we are spinning off a different process for a different purpose. So when I open this other part, it says, and of course, we're going to execute all this in a moment. Then here we get the env from, okay? our environment variables come from the config map and the secret. Okay, so config map ref is simply the reference to our configurations. And remember, config map simply refers to the non-sensitive environment variables. Secrets simply refer to the sensitive environment variables. Okay, so the name will be release.name config. So it will be aero-bound backend config. Okay, which has been defined right this side. Okay, as simple as that. Then for this other one, for the secrets, okay, if values.secrets.create, okay, if it is true, how do you find that this is true? Check again values.yaml, okay. For values.yaml, we see that secrets is false, which means that this part will not be executed, but the else part will be executed. Okay, it will use a secrets.existing name, okay, if it is required. Okay, you get, it will use it. Where will it come from? From here, okay, secrets.existing name, which is backend secrets, as simple as that. And we're going to see how to have this in our CI. Awesome. Then something else I need you to see is the values dev. For values dev, okay, we have secrets to true. Secrets.create is true, and the secrets.existing secret name is empty. Okay, so in this case, for the worker deployment on our local machine or in development mode, we shall have this first part being rendered, error bound secrets. As simple as that. Okay, I hope that makes sense to you. Now that I've explained the worker deployment completely to you, we can now try it out. Okay, let's now deploy it. Okay, to deploy it, the first thing I'll do is to start our, sorry, what's this? Okay, sorry, I need to start our cluster. Okay, in fact, we can even set the services we're going to need. Okay, I'll say Docker Compose. I think I set them in the previous episode. You can just check to see that they're actually running. Docker Compose -f for the file, backend compose.yaml. Okay, the profile will be the local profile. Okay, then you say ps to check for the DB, Redis, and Kafka. So you see they are all up. Okay, up, which is good. Otherwise, if they're not up, then you replace this ps command with up, okay, to bring them up, and you'll be good. So you see all our containers are running. Okay, and now it says attaching to Redis 1, Kafka, PostgreSDB, which is good. All right. After that, a good practice or something that you can want to do is to check for, why is it taking long? Let me stop that. It's saying stop. Let us see. Yes, okay, they're all down. I wonder why it's taking long to start them. Okay, all of them are starting, but let me stop them. I need to start them in detached mode. Okay, so I'll say app -d. Okay, all right, they're all started. This is good. So if I clear this and I say ps, okay, I'm sure by now you guys know these commands. If any command I've typed confuses you, let me know in the comment section. And if you're enjoying this video, please like the video. Okay, like this video. It will help YouTube spread it to so many other people. Then let's go to next command, which is k3d, which is the tool we're using to create our cluster. k3d, we say cluster list. Okay, see the clusters we have. We have the aero-backend-dev cluster. And if you need to start it, you can simply say k3d cluster start. Okay, then the name of the cluster. I'll copy this and paste it. Okay, says unknown command. Okay, look at what my sick head has typed. So I will remove this. It's U then S, hit enter. okay, saying started cluster. So you can start or you can stop. How do you stop? Simply replace this start command with stop, and you'll be able to stop the cluster. All right. Then sometimes you may need to confirm the context, confirm that your kubectl, and kubectl is a tool we use for communicating to our cluster. Okay. You need to confirm that they are connected. Okay. To do that, you can simply say kubectl config, okay, check config, then you say current dash context. Okay, this will help you to check for the current context. See, it says get3d aero-backend-dev, which is awesome. Okay, after that, we can now verify that our Helm chart, okay, this worker deployment.yaml, is accurate and is working. It has no structural errors or format errors. To do that, we shall say Helm, okay, Helm, come on, what am I doing? Helm, then we lint, okay, so hint, what do you want to lint? The Helm backend, okay, and we can say -f to specify the values file we want to specify, and the values will come from Helm backend values dev, okay, .yaml, because this is development, okay. It says 1 chart linted, 0 charts failed. So linting is perfect. We have no linting issue. That is very good. Now the next thing we can do is to render. Okay, we can render and see how it will look like, especially for only this worker deployment. So to render, I can say Helm template. So template again is the command which renders, which gets a Helm chart and renders it into a Kubernetes manifest or a Kubernetes YAML without deploying it. Okay, but it will print it for us to the terminal. So Helm template. Then we specify the release name. The release name will be aero-backend. Okay, and the Helm chart is located in Helm/backend directory. Then -m, we specify the configuration we want to use, will be Helm/backend/values-dev.yaml. Okay, then we can say we want to show only --show dash only for the templates. Okay, templates/worker deployment .yaml. I hope I've typed this correctly. Then I hit enter. So you see, it has rendered the worker deployment for us. And if you see, okay, right here, look at this, look at the name. It says aero-bound worker. But if you come to the template here, you go to the template at the top, okay, and see metadata, it is saying it has 2 curly braces, .release name dash worker. But if you come to the rendered template, are you seeing the expression, the Helm expression has been replaced with the release name. The same for the match labels.app. Okay, the Helm expression. Okay, at this part here, this Helm expression right here, okay, has been replaced with the release name. So if I go back here, you'll see aero-bound worker. The same applies if you go down to the containers, okay, the image, you see, it's called aero-bound local, okay, but this comes from the values dev, okay. If you look at image policy, also has come from the values dev. If you look at the config map ref, it's also aero-bound config. If you look at the secret ref, it is aero-bound aero-backend secrets. Why do I keep saying aero-bound, aero-bound? It is aero-backend. Sorry about that. It is aero-backend secrets, aero-backend config, aero-backend worker, aero-backend worker. So like I told you, this must match this one because this one will create a label, okay, for the pods, and this other one will be used to find pods with that label. Okay, so a label must be created, then there must be a search string to be used to find those labels. So the search string is this first one, and the label creation will happen due to this other one. Isn't that awesome? All right, now that we have seen that our services are up, okay, Redis is up, database is up, Kafka is up, we have a cluster which has started, we have linted, we have no issues with our Helm chart, okay, we have rendered our template, it is perfect, the next thing to do is now to deploy the worker to our cluster. So let's do that. So I'll say Helm upgrade. Okay. What does upgrade do? Upgrade will update, okay, the deployment in case there's a new version of our image. Okay. Or if there is no new update, okay, and it's the first time, then we want to do a minus minus install, okay, to do a fresh installation for the first time. Then after that, we now specify the release name. It will be aero-backend. Isn't that awesome? After that, we specify the location of the Helm chart, which will be in the directory Helm, then backend. After specifying the location of the Helm chart, we can now say minus minus name space, okay? The namespace, we shall give it aero-dev, just like in the previous video, okay? After that, we shall now say, use this namespace called aero-dev, but if it doesn't exist, please create it, okay? Create the namespace, okay? So we are building what is called a fail-safe command, okay? Create the namespace if it does not exist. Then the configuration we want to use is located in Helm. So when you say F, you're specifying the configuration file that you want to use. And what we want to use for development will be in Helm backend. Then it will be called values-dev.yaml. Okay. Then I can hit enter. Okay. So you see, it says last deployed Tuesday, 28th at that date and time. Okay. Namespace aero-dev. Status deployed. Okay. Revision. This is the 8th revision. Okay. Description says upgrade complete. Okay. For your if it was your first time, it wouldn't say, of course, upgrade. Okay. Now this is very, very, very good. So how we have used one image to create two separate containers. Okay. I like this. So I'll clear this up. Okay. And now check out the rollout status. I'll say kubectl. Okay. Minus n. Minus n means namespace. The namespace we just created is called aero-dev. Okay. We say rollout. Okay. Status. Okay. We want to check the deployment. Okay. Say the deployment aero backend dash worker. How is it going? So it says the server doesn't have a resource type. Okay, so I need to fix it. I need to put a / after deployment like this. You see what it says? It says deployment aero-backend-worker successfully rolled out. In fact, if we had just done it, okay, you'd see it saying rolling out. Let me do the previous command quickly. Okay, Helm upgrade, then do rollout. Okay, I would need to first delete that image, okay, to be able to see it rolling out. Actually, let me give you a task. Okay, delete the image. Okay, use kubectl, okay, to delete the image. Okay, and do a redeployment. You will see how interesting it is. Okay, maybe we can try it. Okay, we can delete the deployment. Let us see. Okay, if I say kubectl minus n for the namespace aero-dev get deployments. Okay, so you see we have two deployments. Are you seeing that? For the API worker and for the backend worker. Isn't that awesome? For the API, see, it is saying 3 days, 22 hours ago. For the backend worker, it is saying 2 minutes, 2 seconds. Interesting, okay? Now you can trust this information. Or you can trust what I'm showing you. But you can delete this backend worker, okay? And check out the rollout status afresh. But let me not do spoon feeding, okay? Use kubectl, okay? Using this command, you can replace get with delete, okay? Then you say delete deployment, aero backend worker, okay? Then you reinstall using Helm chart, the template, okay? Using Helm upgrade. Then you check the. I think let's do it, okay? Let me do it. So if you're enjoying this video, please like it, okay? Like it, and after the stream, share it. If you're watching after the stream, please share it and leave a comment. Of course, it helps with this being found by more people on YouTube. You may find that other people find it very useful just because you've liked the video. Okay, YouTube will share to people with similar interests with you. So please like and support. All right, let's try it out. So kubectl, I'll remove get and say delete. Okay, then I say deployment. I'll copy this deployment aero-backend-worker. Okay, do a space, hit enter, hit enter. Okay, so you see it says deployment.apps aero-backend-worker deleted from aero-dev namespace. Okay, so if I say kubectl get deployments, we only have the aero-backend API deployment, which is okay. Now, watch this. I am going to run the command for Helm upgrade install. There it is done. Okay, says upgrade. Then we shall use other command for, where is it, rollout status. Okay, so you see it says successfully rolled out. I was a little bit slow on running this command, but you should have seen it saying process. It would have shown us that it is in process. Okay, then it says successfully rolled out, but this is still fine. Okay, then I can now show you get deployments. Are you seeing? It says the edge is 27 seconds, which is good. If I click it again, I say get deployment, you see it says 35 seconds. I love Kubernetes. I love Kubernetes. It's very simple. Awesome. You can also say get pods by saying kubectl -n is the short form for namespace. The namespace we're interested in is the aero-dev namespace. Then we say get pods. So we're here using kubectl to interact with our server. So you see, look at the pods. They are given that label, then a random string at the end. Okay. So the deployment uses the label, the match selector. Okay. If you ever see anything like selector, okay, just know it is for finding and searching. So using that label, aero-backend API and aero-backend-worker, it finds those pods. Isn't this interesting? I like this. So that's how you can get your pods. Okay. And again, I know you may know these commands, but I do this personally for my personal benefit and also for others, that through repetition of seeing this again and again, it produces mastery. Okay, it produces mastery. Then we can check the services. We can say kubectl -n for the namespace again. The namespace is called aero-dev. Get services. Hit enter. Okay, you see we have one service, aero-backend API of type cluster IP, which means it's for only internal use and it has its own cluster IP port with no external IP. Okay, the age is 30 days, 32 hours, which tells you that we don't have a service for the worker, and this is good. Okay, we don't need a service for the worker. We only need the service for the API. Are you seeing how all this is now making sense? That is why it was important to split the HTTP process from the worker process. Okay, now we can scale the API separately and scale the service also separately. Okay, or you can scale down any at any time. Okay, sometimes you may need many events, okay, which are being fired and you need to consume them, so you scale the worker separately. Okay, using the replicas configuration, even using kubectl, and later we're going to set up horizontal pod auto scaling or auto scaler, and you will see how traffic can be easily managed, okay, by taking it up or taking it down, okay, dynamically. These things are very interesting if you give them time. All right, you can even check for logs. You can say kubectl -n for the namespace. The namespace is called aero-dev. Okay, what command we want to do? Logs, because we want to look at the logs. We want to look at the logs for a particular deployment. Deployment is called deployment, okay, / aero-backend-worker. Okay, then I hit enter. It says command not found kubectl. Okay, so that's my error. I need to fix it. It is kubectl, not lt. CTL, like that. Okay. Looks like my head is now tired. I said -n, m instead of n. All right, so you see, we get some logs, which is good. See, we get notification worker started, okay, fail, okay, connect to this, connection refused. This is okay. Okay, says backend it is a consumer. Okay, says register. handler for events. So say, do you see this? The handlers for user events, booking events, payment events, ticket events have been registered. Okay. I see the security logger configured, blah, blah, blah. Okay. That is okay. Okay. This error is also understandable. Okay. I'm not going to it now, but trust me, if I fire up a request right now, you'll see things working perfectly. Yeah. It is failing because of a certain configuration in Kafka, which can help you determine whether to have your topics created on initialization or not. Okay. Yeah. But let's not get into that. So what else? Yeah, I think I've covered most of the things. Rollout status. Okay. For rollout status, there is something else you can do. You can, if instead of saying rollout status, you can restart. Okay, in case you want to do so. And those of you who followed me when we were doing the Kubernetes, can I call it deep dive by studying Kubernetes, we saw this. All right, I am very happy with how far we've come. If you have any question, this is the time to ask. If you're watching this after the live stream, please leave a comment in the comment section and I will respond to you. I like live streams because it gives me a chance to learn live, to get the tough questions live. And yeah, I just love them. Okay. I love them. All right. Thank you for learning with me and building with me and getting excited. Please like this video and I'll see you in the next live stream or video. So bye for now. Have a very good day, evening, afternoon, night, or morning.